All right, 7.3. Anti-differentiation. By parts. So the basics of today is if I have an integral and I have a function times a different function, so I have two totally different things going on in there, I can actually break this into equals u times v minus the integral of v du. And then you have to integrate the smaller one. Okay? This is the basis of today. So you're going to have to decide what you want your u to be, what you want your v to be, or dv to be, and then we're going to get all of the pieces put together. There you go. All right, so since this is all we're doing, I want you to go ahead and we're going to do an example number 1. We're going to see how this works. So we're going to integrate by parts, and I'm going to leave that formula right up there. Let's start by doing the integral of x cosine x dx. So the antiderivative, or the derivative of cosine x is not x. So we don't have anything to use as our, like to do a u substitution. So we have to find something different. In this case, I want to make my x out in front my u, and my cosine x dx, I want to be my dv. So I'm going to come over here and say u equals x, which means my du equals 1, or 1 dx, I better say. And then my dv is going to be x cosine x dx, which means my v is the antiderivative of that, not x cosine, just cosine x. Sorry about that. I'm just writing too much. All right. So my v, or the antiderivative of cosine x, is sine x. So now that we have all 4 pieces, we're going to plug it into our formula. So we have u times v. So x times v, which is sine x, minus the integral of v sine x du, which is 1 dx. So now I just got to integrate the second part. So I have x sine x minus, what's the antiderivative of sine x? Negative cosine x. That makes that a positive. Cosine x plus c, because obviously we have no bounds here, so we have to put plus c at the end. Okay, so we're going to fill in those 4 spots and then plug it into our formula. Any questions so far? Okay, let's try another one. Let's go with example number 2. All right, let's say I have the integral of x natural log x dx. Now this one's a little bit trickier, depending on what you want to use for your u. Now I personally, because if I were to take natural log x dx, there is no antiderivative to natural log, right? So that means that we want to use our x dx as our dv right here. And this is going to be our u. So I have u equals the natural log of x, and my dv equals x dx. The derivative, or du, Derivative of natural log x is 1 over x dx. The antiderivative of dv, or v, equals what? Good. X squared over 2. Perfect. All right. So now we do u times v. U times v. So natural log x times by x squared over 2, which we're probably going to write in front, minus the integral of v times du. What do you notice? Yeah, we can reduce that. When we do it that way, we can reduce our x squared and our x. So we can cross out this x with 1 here. So really, I just have to do the antiderivative of 1/2 x. So I have, and I'm going to flip this around so it's in the front, x squared over 2 natural log x minus, what is the antiderivative of x over 2? Remember, we add 1 to the exponent. Well, we've canceled one of the x's here, right? X squared over 2, and there's already a 2 there, so it's x squared over. Do you want me to say that again? I'm not saying this right, huh? Okay, let me back up a little bit. Right here, we canceled this x with this x. So all we have in here is x over 2. So I have 1/2 antiderivative of x is x squared over 2. There we go. So I just had to write it down. X squared over 2 natural log x minus x squared over 4. And what do I have at the end? Plus c. All right, let's do example number 3, and then we're going to go to a different method. Okay, so example number 3. I want to make sure I'm covering everything. All right, let's do this. The integral of x e to the x dx. So we've got to decide what our u is going to be and what our dv is going to be. What do you guys want to do? Okay. Okay, if that's what you want to do, we can. So you want this to be e to the x, and you want this to be x dx. Okay, so that means my du is e to the x dx, and my v, x squared over 2, right? Okay, so now we do u times v, or 1/2 x squared e to the x minus the integral of v du. X squared over 2 times e to the x dx. What do you notice? We're stuck back at the same place, aren't we? Because we still have an x and an e to the x. Right? Okay, so let's backtrack and try flipping those and see if it makes any difference. All right, so we're going to go back and try again. So we're going to flip our u and our dv. So this time, let's make our dv e to the x dx, and let's make our ux. The derivative of x is 1 dx. The antiderivative of e to the u, or e to the x, is e to the x. All right. So now we do u times v, or x e to the x, minus the integral of v du. Now can I integrate that second integral? Yeah. So this is going to be x e to the x minus antiderivative of e to the x is e to the x plus c. So our first three examples, we're doing it by parts. There is another method called the tabular method, which some students actually prefer. So we're going to talk about that. It doesn't work all the time, but it works if one of the pieces will get down to nothing, like get down to 0. So, tabular method. In the tabular method, if I have a integral of f of x times g of x, so two different functions, right? We're going to take one function, the function that will eventually derive all the way down to 0, goes here, f of x, and we're going to do the derivatives on this side. And then over here, we're going to do g of x, and we do the antiderivatives. All right, and we're going to make a list until we get to 0. Then, once we do that, we are going to actually cross our lines and multiply to the next one down, and I'll show you how that works. And then our signs alternate, positive, negative, positive, and so on. All right, so that's the method on how it works. It's going to be a lot easier to see once we do one. Okay, so here's example number 4. Using the tabular method, let's say I have the integral of x squared e to the x dx. All right, we just did one similar to that. We're going to take our first function, which is x squared over here, and we're going to take our second function, which is e to the x over here. This side we do the derivatives. This side we do the anti. All right, so on the left I have x squared, which becomes 2x. Derivative of 2x is 2, and the derivative of 2 is 0. On that side, we do the antiderivative. Antiderivative of e to the x is e to the x. Antiderivative of e to the x is e to the x. And you go until you're across from 0, which is e to the x. Now you diagonal it, so this one's going to multiply by the second one here. This one's going to multiply here, and this one's going to multiply here. And we go positive, negative, positive. So the antiderivative of x squared e to the x is e to the x squared, or x squared e to the x. We better write it that way, sorry. X squared e to the x is better. X squared e to the x minus 2x e to the x plus 2e to the x plus c. This works if one of the functions can derive all the way down to 0. So like if your two functions like sine and cosine, they never get to 0, right? Or e to the x never gets to 0. But if one of your functions can derive down to 0, this works. Yeah, that won't work. Yep. All right, let's try example number 4. Let's do it again. Example 4. Let's do one a little bit tougher. Let's say I have the integral. Oh, it is? Okay. No, example 5? Yeah, you're right. So x to the, let's do x to the third sine x dx. We can do this one by the tabular method because one of the functions can derive down to 0, right? Which one? Good. All right, so we're going to start on this side with x to the third. So I have x to the third, which is 3x squared which is 6x, which is 6, and 0. Over there, I start with sine x, but I do the antiderivative of sine x, which is negative cosine x. Then I do the antiderivative of negative cosine x is negative sine x. Antiderivative of negative sine x, good. And then antiderivative of positive cosine x, sine x. And now we do our diagonals. Yep. Positive, negative. But what will you notice? Right here I have two negatives together, right? Or here I have a positive times a negative cosine. Yeah. So we're going to start here, and I have a positive x to the third times negative cosine x. So I get negative x to the third cosine x. Here I have a negative and a negative, so it becomes positive. 3x squared sine x. Then I have plus 6x cosine x minus 6 sine x plus c. All right. Now, the only time it gets a little bit tougher is if, which is going to happen, and we're going to talk about one, is if on this side when we're doing the antiderivative, there's more than just an x behind it. So let's say it was like a 2x here, right? We'd have to do a u substitution. So then we'd be dividing the 2 over, right? So then we have a 1/2 and then a 1/4 and then a 1/8. That's all going to happen in front. So let's try one like that. So here is example number 6. And if you guys are good, this might be our last one. If you guys are all feeling good about it, let's go with the integral of 2x let's do 2x squared cosine 3x dx. All right, so 2x squared goes over on this side. 2x squared. Derivative of 2x squared is? 4. Good. Derivative of 4x? Then 0. Awesome. Over here is where it's going to be a little bit tougher. I have the cosine of 3x. So remember that we would have done a u substitution for 3x, which means that our du would have been 3dx, and we would divide the 3 over, right? So my antiderivative of cosine x is going to be 1/3 sine 3x. What about the antiderivative of 1/3 sine 3x? Well, first of all, when we go to sine to cosine, it's going to be negative. Go ahead. Yeah, well, so this is going to be negative 1/9. You're right. Cosine 3x. And what's the next one going to be? 127. Yes. Positive or negative? That would be a negative. Good. Negative 1/27 sine 3x. All right, let's go ahead and draw our diagonals. Positive, negative, positive. And here we go. 2x squared times 1/3 sine 3x. 2/3 x squared sine 3x. And the next one I have a negative times a negative, which is going to be a positive. 4x times 1/9, or 4/9x cosine 3x. I have negative. You all done? Yeah. Oh. Or not all done, but. Okay. Put it back here till next time. Okay? Perfect. Thank you. Then I'll have to check your notes tomorrow or something, okay? All right. So here we have 4 times negative 127. So it's going to be negative 4 over 27 sine 3x. And then what? Plus c. Exactly. So those are going to be the toughest ones, is when you have something going on behind it that you've got to multiply to the front. Okay? But I think most students prefer the tabular method over having to do the parts, unless you absolutely have to do it by parts. All right, so your problems 1 through 10 to do. If you get started right now, I'll be able to help or answer questions as we go. And this way I can answer your questions you gave from yesterday. Right?